Okay, everybody, we're going to review sequences. We're given a sub 1, the first term of a sequence, which is 5. You're given the common difference, which is negative 3. So here we have a sequence of 5, minus 3 is 2, minus 3 is negative 1, minus 3, and so on, all the way to a sub n minus 1, which comes right before a sub n. So if n is 20, 20 minus 1 is 19, okay? All right, so the formula for the nth term, the general formula for any term you want in the sequence, a sub n equals a sub 1, the first term, plus n minus 1 times the common difference. Remember, we'll apply the common difference one less time than the actual term number. Notice I apply the common difference 1 time for the second term, 2 times for the third, 3 times for the fourth, 4 times for the fifth. So that's where you get the n minus 1. For the fifth term, we'll apply the common difference 4 times. Okay, so here's our generic nth term sequence. A sub n equals 5 plus n minus 1 times negative 3. The first term, the common difference. Okay? If you're asked for a recursive formula, it's very basic. It's basically you have to, on a sequence, an arithmetic sequence, you have to be given the first term, and then basically to get a term, you take the previous term and apply the common difference, in this case of minus 3. A sub n equals a sub n minus 1 minus 3. Okay? To get 2, we take 5 minus 3. Okay? So to get a term, we take the previous and apply the previous term and apply the common difference. All right, for the 34th term, a sub 34 equals 5 plus 34 minus 1, which is 33, times the difference of negative 3. And the 34th term is negative 94. All right, remember this formula? The nth term is a sub 1 plus n minus 1 times d. All right, you'll definitely see that. Okay, now let's try page 2. Let's see how this works out. Okay, now we're going to be given a sequence, and we need to find the indicated term in the sequence. In this case, let's find the 75th term. But here we're not given the common difference. So you're given a sequence. First, just make sure it's arithmetic. Okay? Make sure you have a common difference. And we do that by taking a term and subtracting the previous term. Negative 2 minus 1 is negative 3. Negative 5 minus negative 2. Negative 5 minus a negative ends up being a plus, and that gives us negative 3. Negative 5 and positive 2 is negative 3. Negative 8 minus negative 5, term minus the preceding, is negative 3. So negative 3, negative 3, negative 3. Looks like an arithmetic sequence to me. D equals negative 3. Okay? All right. The nth term equals a sub 1 plus n minus 1 times d. In this case, we want the 75th term, so that's 1 plus 75 minus 1 times negative 3 is negative 221, okay? So that's our first term, right? A sub 75 equals the first term 1 plus basically 74. That's what that is, 75 minus 1, 74 times negative 3. Again, negative 221, all right? Let's try page 3. Okay. Find the first term now, and here we're not given a sequence. We're gonna be given, hey, the fourth term is 3 and the 20th term is 35. Okay, so from this, let's find the first term and the common difference. So find the first term, the recursive formula, and if we have the recursive formula, we're going to need a sub 1 and d, and then with all that, we can get the general formula for the nth term. Okay. A sub n equals a sub 1 plus n minus 1d. All right? You can kind of work this out without doing below. Basically, I know when we go from the 4th term to the 20th term, that's 16 terms, and I go from 3 to 35, that's a difference of 32. Okay? So that's basically 32 and 16 terms, so the common difference is going to be 2. But look what I do here. I kind of set up a system of equations, which is a surefire way to do this correctly. Okay, a sub 4, fourth term is 3. So how would we get that? Remember this general formula here of a sub, we know what a sub 4 is. Guess what? It's 3. So I'm going to take a sub 1 plus this n minus 1, 4 minus 1 times the common difference. So a sub 1, 4 minus 1 is 3. A sub 1 plus 3d equals 3, right? Then I take the term, the a sub 20, the 20th term, which we know that value. We would get that from what? The first term plus n minus 1, 20 minus 1 times d. And that's a sub 1 plus 19d equals 35. So now we can use elimination of our system of equations. And notice what I did here. I put the bigger numbers on top just so I don't have negative numbers, okay? And I just subtract this sequence from this one, the whole sequence. So this minus this minus this minus this, and so on, okay? So a sub 1 minus a sub 1, guess what? We eliminated that. So now we're down to one variable. 19d minus 3d is 16d. 35 minus 3 is 32. Okay, so 16d equals 32 divided by 16. Each term as we go is plus 2, plus 2, plus 2. There's our common difference of 2. All right. So we've got our common difference, and all we have to do now to go back and get this nth term, we've got this, we need this. So just go back to this, either one of these equations, and plug in d and solve for your first term. Okay, I use this sequence for the fourth term. Okay, and I said a sub 1 plus 3d equals 3. Well, we know what d is now. So a sub 1 plus 3 times 2 equals 3, which is 6. A sub 1 plus 6 equals 3. I subtract 6 from both sides and get a sub 1, which is negative 3. 3 minus 6 is negative 3. So I know a sub 1 equals negative 3, d equals 2. Here's our recursive sequence, right? We need the first term, a sub 1 equals negative 3, and just basically, hey, nth term is the preceding term, and apply the common difference. A sub n equals a sub n minus 1 plus 2. The nth term formula is just a sub 1, and we got the common difference here. So a sub n equals negative 3 plus n minus 1 times 2. Okay? All right? So that's when we just, like I said, we could have, this is a good way of doing it. Okay? All right. See, let's try this one. All right, let's review. Now we're going to talk about summing up the sequences and kind of using formulas, not using the equation, or not using the calculator so much with the sigma notation. Okay, here's the first 100 integers, 1, 2, 3, 4, dot, 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 9, all the way up to 97, 98, 99, 100. And I kind of showed my classes this. Notice 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98, 101. 4 plus 97, 101. And we can keep going. If you sum up the first 100 integers, there's basically 50 pairs, right, of 5 and 95. 6 and 94. You have 50 pairs of 101. I'm sorry, it'd be 5 and 96. Sorry about that. 5 and 96, 101. 6 and 95, 101. Okay, so 50 pairs of 101 is basically 50 times 101. Okay, here's basically what we did. We took the first term and the nth term, in this case 100, first term, which is 1, plus the 100th term, which is 100. So that's the first term plus a sub n. And how many terms? 100. So 100 over 2 times 1 plus 100. So here's your formula. This is the sum of the n terms of this sequence a sub n. So S sub n is the sum of the first n terms of sequence a sub n. Okay, a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub n. Okay, you take n over 2 times the first term and the a sub n term. Okay, there's your formula. A sub 1 plus a sub n in parentheses times n over 2. All right, here's an example. 2, 4, 6, all the way up to 70. So we want to sum up these terms, okay? Trick is, here's our formula. The sum of these first n terms equals n over 2, and we know the first and the last term, 2 plus 70, but what is n? How many terms did you go through to get 70? Okay, so we're going to go back to this formula where we're going to solve for n. We know the nth term is 70. We know the first term is 2. We just don't know what n is. We know the common difference. 4 minus 2, 6 minus 4. The common difference is 2. Okay? So look what I use this formula here just to find n. So I know it's 70 equals 2 plus n minus 1 times 2. And notice 2 times n is 2n, and 2 minus 1 is negative 2. And down here, I kind of take off the parentheses. So I have 2 plus 2n minus 2. Notice 2 and negative 2 is 0. Okay? So basically 70 equals 2n, and we divide both sides by 2, and n equals 35. Okay? So now, here's a case where we know that a sub 1 and a sub n, we just don't know what n is. And that's where we plug in this equation, 70, first term, common difference, and solve for n. N is 35. So now we can use our formula. Okay? The sum of the first 35 terms is 35 over 2 times 2 plus 70, which is 1260, 1,260. Okay? All right. Last page. I'm doing good on the time. All right. Here's our formula again. S sub n equals n over 2 times a sub 1 plus a sub n. But what if you're given something like this? 2, 6, 10, 14, and we're not given the nth term, but it says find the sum of the first 25 terms. So here we know what n is, we just don't know what a sub n is. So you can on your own just figure out a sub n by using this formula, okay? We know how to figure out the nth term, right? We've got a first term and a common difference, so we can figure it out. But here's where it is. Here's n times 2 times the first term plus the nth term, right? Here's our formula for the nth term. A sub 1 plus n minus 1 times d, okay? And notice if I take out these parentheses, I've got an a plus 1 plus a plus 1. That's going to be 2a plus 1, and what's left is just n minus 1d. So this is another formula. Let's say you can just figure out, if you want, you can figure out that nth term on your own because you know how to do it. But here's another version of this formula. Same, it's going to work, where it's n over 2 times the first term plus n minus 1 times d. Okay, so in this case, we want the first 25, the sum of the first 25 terms. Okay, so 25 over 2 times the first term, which is 2 times 2, plus 25 minus 1, which is 24, and the common difference is 4. So this is 4 plus, this is 96, which is 100, and 25 over 2 times 100 is 1250. Basically, because 25 times 100 is 2500 divided by 2 is 1250. Okay? I wrote that wrong, so disregard that. Here's your formula right here. Okay? N over 2 times 2a sub 1 plus n minus 1 times d. So that formula is just a way of getting your first term plus the nth term when you don't know it, okay? And this one's when you know that, okay? That's it. All right, that's 13 minutes. This is what we're going to go into tomorrow is the sums, okay? And a little bit of review. All right, thank you.